In this lesson, we'll try to add a bit more functionality to our application that our previous refactorings haven't anticipated. We'll be using almost all of the refactorings we've learned so far. I'll not be listing the keyboard shortcuts all the time. The business has come along with another new requirement, that customers should receive a 5% discount if they rent 5 or more times. Let's write an end-to-end test for this new feature. Of course, in this test system, the ends are not very far apart, but the concept is there. Having real end-to-end tests is important, because even though functionality may be present in a system, it can be easy to forget to plug it in, or to enable it. Note, however, that the number of end-to-end tests is very few compared with the number of unit tests, and while we've been refactoring, we've been decreasing the percentage and number of end-to-end tests. Anyhow, let's write an end-to-end test to show the new behaviour required. Clearly, the test should fail, as the code doesn't support the idea of discounts yet. Click to see the difference to get a good idea of the difference in output between our current implementation and the desired output. Now we have a failing test, let's have a look at how we might implement it. Look at the statement generator. This does two things. Firstly, it prices each rental using the price plan. Then it renders the text statement. A class that does two things is a bit of a warning sign that it's not correctly factored. We did create this class in an earlier refactoring, so how come we got it wrong? Well, it did help us separate out the tariff and loyalty plan, so it was quite helpful. And it's important to realise that refactoring is a stepwise process with incremental improvements, either in clarity or for some other functional reason. This code was incrementally better than that which was there before, even if it's not perfect. The issue here is that price plan would seem to be a good place to put a discount, but it only seems to know how to price a single rental. Let's introduce a new object, statement, that holds all of the information required to generate a text statement. However, as we are now refactoring, we need the support of all of the tests to make sure we didn't break anything. Let's ignore the test for the new feature so we can rely on a green build while the refactoring happens. Is the build green now? Yes, so we can refactor. So, let's introduce a statement class, just like last time. New statement, assign variable, add inner class, make static. Now, let's make the statement rendering in terms of the statement object. Firstly the name, then the priced rentals. Now the total, by adding a method total on the statement class. Now that the total amount field isn't used, Alt-Enter will get rid of it, and the now useless additions. Next, for the loyalty points, and remove the now unused frequent renter points variable. Quick check for the tests. Good. Still passing. Now, introduce a method that prices the rentals and returns a statement, and make it public. And we can move it onto the price plan with F6. Go back and introduce statement as a parameter to the method. This will put the code calling the plan.statement into the caller, which in this case is the customer class. It will also remove all the other now unused parameters. Note that our tests stay working all the time while refactoring, so we have almost complete confidence that we didn't break anything. This class doesn't generate a statement anymore, it renders one. So rename the method render and the class statement renderer. Move to the caller of render with Ctrl B and rename the variable generator to renderer. Now, navigate into the statement method of pricePlan. The pricePlan implements the function interface, but I don't think it's used anymore. A quick check is to find usages with Alt F7, then say no to the dialog, as we want to find usages of the interface when it's used on this exact class, not just part of the functional interface. IDEA thinks it isn't used, but sometimes it's hard to tell exactly, especially with very generic interfaces. The compiler will be able to tell us. Let's inline the apply method into the map, removing the method. First, we need to make the apply call explicit, then inline with Ctrl-Alt-N. IDEA warns us that this means our class will no longer implement the function interface, but that's what we want, so Alt-C to continue. F2 to jump to the error and remove the implements phrase. Shift F10 to check. Still, the tests are all good. Now to make the statement a top-level class. Navigate to the statement class. Currently, we can't do it, as the field priced is private. But we know that it's used by the renderer. And although we have actually done this already in the codebase, exposing collections outside a class is fairly bad style, because it makes it confusing as to the owner and mutability of the collection. If a method returns a list, is it mutable? What happens if somebody changes it? Do you need to copy it? And for how long is the collection valid? For this class, we'll try another mechanism, an internal iterator. We can pass in a consumer that will be called for each price rental, keeping the list implementation detail hidden away. Let's write the each method. Now to use it. Right, there's a problem. We can no longer use string concatenation, as variables referenced in lambdas have to be final or effectively final, so we need to use a string builder. Notice how you can use complete statement or Ctrl-Shift-Enter to sort out all the brackets and semicolons. The statement name is still public. Let's replace that with a method call by using encapsulate field with Alt-R-E. IntelliJ will convert usages of that field into a method call. Rename getName to name. Test still OK? Good. Here would be a good place to check in, as we've completed our refactoring, everything is still working, and we haven't broken anything by trying to add the new functionality. Now we can unignore the test for the new feature. Inside the price plan, we can add a new class, Discount Calculator, that, given the priced rentals, can return the discount percentage that should be used, then pass the discount to the statement. make the discount calculator a field, initializing in the field declaration. We can implement this simple discount calculator. Ideally, this would be tested with a unit test. Then, add the discount percentage to the statement class. Going back to check the requirements, the renderer needs access to both the discount amount and the new discounted total. Assuming that we only use the total method for the current display and not for any billing purposes, we can just add a new method discount that returns these values. Then, finally, sort out the rendering of the discount in the statement renderer. Run the tests, they all pass, and our new feature is done. Once again, we added a new feature by refactoring first to make it easy to add the feature. The refactoring took a little while, then adding the feature was very simple. This is often a much better approach than adding the feature first, then refactoring afterwards. Note that if we take a quick look over our complete codebase, the majority of the code hasn't changed. This is a good sign, as it means that our code is reasonably well factored. We don't have to change all the code everywhere to add a new feature.